The visualization illustrated JWT Lifecycle, tracing the flow from the initial authentication to the execution of secure API requests. Use like this architectural diagram to examine the two essential phases of token measurement, the authentication track for token issuance and the API request track for validation and usage. Following this, I demonstrate how to implement JWT security within a NestJS controller using the UseGuard decorator, leveraging an identity token retrieved from Firebase Auth. To begin, we integrate the necessary dependency, specifically NestJS Passport, Firebase JWT, and Firebase admin. You can initialize this package using npm. Next, we access the Firebase console to configure our project. Within the project setting, navigate to the service account tab to generate and download your private key. Move the Firebase key.json into your local directory. Afterward, we structure a dedicated Firebase module to encapsulate our authentication logic. Inside the Firebase module file, we start by importing the core NestJS module utilities, the Firebase admin SDK, and the Passport module. We will then define a variable for a custom Firebase provider, named Firebase App. For the implementation, we utilize a uFactory function to handle the initialization logic. For handling a Firebase credential, we have two approaches. Option 1, create a credential using environment variables. Option 2, use the credential directly from a JSON file. While you can securely inject credential via environment variable, for this demonstration, we initiate the credential directly from our JSON service account file. Once the admin initialize app method is configured with this credential, we wrap everything in the module decorator, ensuring the provider is properly registered and exported for use across the application. Now we implement the FirebaseStrategy to handle token validation and authorization. This class serves the bridge between your incoming request and the Firebase admin SDK. First, create a FirebaseStrategy.ts file. We define a FirebaseStrategy class that extends Passport.js. Through this, we import the necessary utility from NestJS Passport and the core Firebase admin SDK. We specifically utilize strategy and structure JWT from the Passport Firebase JWT library. The strategy name, we label this as Firebase. Inside the constructor, we call super to initialize the base passport configuration. Token instruction, we set JWT request to extract JWT from auth header as barrier token. This utility automatically passes the authorization header and isolates the bearer token for further processing. The heart of this strategy is the validate method. This is an asynchronous function that receives the extracted token as its primary argument. Inside a try-catch block, we define a Firebase user variable. We then await FirebaseAdmin.org.verifyID token. This method performs the cryptographic handshake with Firebase to ensure the token is authentic and is spy and hasn't been tampered with. If the token is valid, the function returns the Firebase user object. NestJS then attaches this user object to the request object, making it accessible across your controllers. If the token is malformed or invalid, the catch block intercepts the error. Here you should throw an unauthorized exception to ensure the API responds with a proper folder invoice status code, avoiding regarding your protected route. Once the strategy is defined, we need to integrate it into the NestJS dependency injection system and get a reusable guard for our routes. In Firebase module.ts, we register the passport module within the import array. By calling passport module.register default strategy as Firebase, we establish our Firebase logic as the primary authentication layer for this module. Ensure that your Firebase strategy is also listed under providers to make it available for dependency injection. To protect our endpoint, we encapsulate the authentication logic into a dedicated card. Create a new file named FirebaseAuth.guard.ts. In the file, we import the injectable decorator from the NestJS command and the AuthGuard utility from the NestJS Passport. We define a class named FirebaseAuthGuard that returns the built-in AuthGuard. We pass the string Firebase as a parameter to the AuthGuard constructor. By extending the base AuthGuard, our custom guard inherits the complex logic required to trigger the passport strategy, handle the request response lifecycle, and automatically manage unauthorized access. You can apply this guard to any controller or individual route using the use guard decorator. Then we import the Firebase module and FirebaseStrategy into the app module. Before we secure our endpoint, let's verify the current state of our API. First, we execute a target to the request endpoint without the authentication guard. At this stage, the API is entirely public. You should see a successful response regardless of whether a token is provided. Now we restrict access by applying the FirebaseAuthGuard to our controller. Using the use guard decorator add an endpoint ensure that the route within this class now require a valid Firebase ID token. Once applied, the guard intercepts every incoming request. It delegates the credential to our passport strategy, which validates the bearer token. If the token is missing or malformed, the request is rejected immediately with a 401 unauthorized status, preventing unauthorized access to your logic. We attempt a request by providing an incorrect or malformed token in the authorization header. As expected, the API returns a 401 unauthorized status with an invalid Firebase ID token message. This confirms that our validation method effectively catches the error and prevents unauthorized access. Next, we forward dummy string for a genuine Firebase ID token generated from the client side. We send the request again, ensuring the token is prefixed with the bearer keyword. With the valid credential, the FirebaseAuthGuard successfully authorized the request. The controller logic executes and we receive the expected response data. This end-to-end test demonstrates that our strategy is correctly communicating with the Firebase admin SDK to secure our NestJS endpoint. If you found it helpful, hit the like and subscribe button for more deep dive into AI and full stack development. See you in the next one.